Hello everyone, this is day 17 of the 30-day series of the Identity Foundation. So this is the continuation of the previous session where we'll be talking about OAuth 2.0. So OAuth stands for Open Authorization. Okay, this is the Open Authorization. Now, initially we discussed about SAML. SAML is primarily used as a authentication protocol. So whenever you want to prove who you are, that's where you're using SAML. But once you have proved who you are, when you need access, that's what we call as authorization. Okay, this is where we call as authorization. So the overall authorization framework it's basically an authorization framework that enables third-party applications to access resources on behalf of a user without requiring the user to share their credentials. Now I'll give you an example. Most of the time you would have logged into any application. Okay, any application, and it'll give you three options: log in with Google, log in with Microsoft, right? And you choose any one of them. Now, what happens here is this application goes to Google and gets the user information and uses that user information to create a user profile. Okay, or just give you relevant access. This is a typical example of OAuth. So let's understand how OAuth 2.0 SSO works. The first is the user attempts to access a resource on the relying party in OpenID Connect terms. Okay. We already know what SP and IDP is here. But in this, we'll have client and the IDP, or also called as resource server. Okay. The client is typically the application that you are trying to log in, which could be Salesforce, ServiceNow, Jira, SAP, Workday, anything. And IDP remains our products like Ping, Okta, Entra, all these IDP is acting as a resource server. Okay. Now, first, again, as a user would attempt to log in, they will attempt to click on the application. Then we have the client redirects the user to the authorization server. So here, I would like to explain you there are three different boxes. Okay. And I'll just show you a diagram. So I'll reshare this again. So here, if you see, these are the different components. Okay. So the first component in this diagram is your authorization. This is the authorization server. The first one is the authentication endpoint, authorization endpoint. Sorry. Then you have the token endpoint and the user info endpoint. Okay, if you remember, this was the same snippet I had shared across in one of the teaser. Okay. So, and this is the client. Now, what is happening is client is going to the authorizations endpoint and saying, hey, I would like to get some detail. And when it is going with a certain request. This is where you can find the request. And then the authorization endpoint is providing them a response, which is in the form of a code. Okay. And this code is now consumed by the client and client makes the second flow. So this you can term as flow one. Yeah, the flow one. Save changes. Okay. Then in the flow two, what is happening? The client is again going back to token endpoint. Okay. Again goes back to the whole resource server where it is going and talking to the token endpoint. And it in that exchange, in that request, it is actually taking the same code that it received here. Okay. It takes the code, goes to the token endpoint and says, hey, here is my code. Please give me a token. And then the token endpoint would give them the token back. And in that journey, it takes that token, goes to the user info endpoint and says, here is the token that I have got. please give me the user info. And this is how, if you see, the token would look like. Here you will have the access token, refresh token, the expiry time, and the token type, which is bearer token. Bearer token is any token that you can use over the internet during these type of transactions. Okay, so this is where we can typically see how the entire OpenID Connect or OAuth is working. Okay, now here I just wanted to show. So this is a user logging in. This is your IDP. Now here there is a username and a password, and the client is doing the back and forth with the IDP using the protocol and then establishing this session. So after all of this, the user gets a session. Now this session token or cookie is exchanged across on the browser level, which is the agent. And if your token validity is 1 hour, then you'll be able to be logged in for 1 hour. If it is, most of the time is 3600 seconds, which is 1 hour. And then that is one of the reason you are able to achieve single sign-on. Now this token will ensure that when you log into another application, it is shared and you don't even see the login screen. Same thing happens. So on the back end, it's the cookie that is actually playing a major role to establish a session. And you are only able to establish a session when you're getting a token. You get the token once you complete the authentication process. And to complete that authentication process and get a token, this is the back and forth that the client is doing. Okay, so let's move on to our discussion again. So advantages of OAuth: simplicity, because OAuth 2.0 is relatively simple to implement and use. Flexible, because it is used for various of authorization, varieties of authorization scenarios, and very mobile friendly. It's well suited for mobile applications. The couple of disadvantages where there are security considerations, and definitely the reliance on HTTPS. It requires HTTPS for secure communication. So this closes off our OAuth. Now let's move on to Kerberos. Kerberos is a network authentication protocol, but also very widely used on desktop authentications, okay? The client server applications. It relies on a trusted third party, the key distribution center, to authenticate users and services, which we call as KDC. So how is Kerberos SSO work? How does it work? The user requests a ticket from the KDC. The KDC authenticates the user, put username and password, and then issues a TGT, ticket granting ticket. The user presents the TGT to the KDC and saying, here is what I've got. And the KDC issues a service ticket. The user then presents that service ticket to the application. So in the previous case, let's say in the case of OAuth, it's token. In the case of SAML, it is the assertion, and inside the assertion, you have different attributes. And in the case of Kerberos, it is the ticket. And then the application, in all the cases, who's validating this? Application is validating this. The assertion and fetching the user information, or the token or the ticket. Okay, so all of this is summarizes how Kerberos SSO works. This plays a very important role whenever you are doing any desktop level application. Okay. Most of the time you'll have Kerberos enabled. Advantages: strong security has been used from very long time, centralized authentication, mostly on the Active Directory level. Efficiency. Efficient can handle large number of authentication because this has been in use for a very long time, almost like 2-3 decades. But what are the disadvantages? Complexity. It's very complexity, like complex to kind of go into the whole world of TGT and KDC and all of this. Reliance on KDC. Kerberos relies on trusted KDCs, which can also be a single point of failure. If KDC is down, then definitely it is not going to work. Your Kerberos authentication fails and users will not be able to log in. The other is this also relies on time synchronization. Kerberos requires accurate time Sometimes the server and client doesn't have a sync, it starts failing. Then out of these protocols, you also have custom SSO solutions. Okay. But custom SSO solutions provides flexibility and control. But also the moment you talk about customization, there is a cost, complexity, resource issues. And if you are customizing, there could be some libraries, common libraries or open source libraries. And those can bring in security risks. Okay, if not properly designed and implemented. So some of the security considerations for SSO, the purpose we must consider is SSO is primarily used for authentication purpose. Eventually trying to ensure that you have a secure communication. Overall, the session management should be very seamless. It should not be that one set of applications are receiving 1 hour, other set are receiving 2 hours, and in 10 minutes you have to re-log in again. In all these systems, vulnerability management, regular scan and patching should be a key, and there should be a proper access control limit user access to only resources that they would need, eventually ensuring auditing and monitoring is in place. So this summarizes single sign-on, in which we have discussed about SAML, OAuth, Kerberos, and any customized protocols. Okay, so thank you very much. I will see you in the next video.